Alrighty, guys. Hope all is going well with you. I am going to be going over worksheet 6-6A, just the beginning of it, all right, where I'm going to introduce graphing sine and then graphing the cosine function on a coordinate axes. And then we'll talk about some characteristics of those graphs, specifically amplitude and period, okay? So you can see here that I've included the unit circle here. And if you remember, right, unit circle means that the radius is 1, okay? 1 unit. So what we're going to do today is we're going to take this unit circle, right, and unwrap it on this coordinate axis, all right? Now, when I introduced the unit circle to you, we talked about the fact that x and y correspond in the unit circle directly as cosine of theta and sine of theta, theta being your reference angle. So if I were to draw a right triangle to this point, right, square root of 2, comma 2, and square root of 2, comma 2, right, that would mean the x coordinate is that long, right? The y coordinate, that's how high I would be going, which is about 0.7 if you put that in your calculator. And then my radius would be 1, okay? So therefore, if you think about it, right, this is a 45-degree angle because the sine of 45 in a 45-degree angle would be root 2, if we're using our 45-degree angle, right? We usually label this as this is 1, this is 1, this is the square root of 2. But notice that's not the same as this because the hypotenuse is the square root of 2. Okay, here the hypotenuse is 1. But if I take the sine of 45 degrees, right, and I do 1 over root 2, that becomes rad 2 over 2. So the sine of 45 degrees is rad 2 over 2, which is what, right, my x, because that's cosine, right, and my y, which is sine, that's the value of it when we have a hypotenuse of 1, okay? If we go into, let's say, the second quadrant, right, and I draw a special right triangle to this one, right, to this guy, you can see this is at 5 pi over 6, so that means my reference angle is pi over 6, which means this is a 30-degree reference angle. And usually with a 30-degree reference angle, right, we would have 1, 2, rad 3. So the sine of 30 degrees would be 1 over 2. Now, if you look at the triangle drawn in the unit circle, the radius has to be 1. Well, the sine of 30 degrees in our special right triangle is 1/2. So that's the y coordinate here. Okay, and then the x coordinate is negative because cosine is negative in the second quadrant, and that would be rad 3 over 2, right? So then this is rad 3 over 2. Now you could go to all the other quadrants, but you can see that now we have all the sine values starting here, right? Then at 45 degrees, then here, this would be at 60 degrees, right? Then at 90, that would be 1. Then rad 3 over 2, rad 2 over 2, the 1/2 we just talked about, then 0, and so on and so forth. Now, you can see the same values keep popping up, don't they, right? Here, it's always 1/2, rad 2 over 2, rad 3 over 2, or 1, and then the signs change. And we go around our circle, right, positive or negative, depending on what quadrant we are in, and then we come back here. Now, if I ask you for the sine of 400, right, and then I would go around one whole, and then back up here, right, I would get the sine of 45 degrees here, even though this is an angle greater than 360 degrees, right? So that would be 360 for 415, right? Which is really the sine of 45 degrees, right? And then we would have our reference angle of 45 degrees, and then we would get the sine of 45 degrees and come back to this rad 2 over 2. That's because sine and cosine are what we call periodic functions, okay? Periodic functions are functions that repeat to the same value after a given period. Now, if you look, sine repeats itself, right, after a whole cycle, which is 360 degrees, or in radians, that would be 2 pi, okay? So it's cyclical or periodic, and it just repeats its values, okay, which we've been using when we've been evaluating sine, cosine, tangent, or different trig functions within the 4 quadrants, okay? Now we're going to take those values and actually put those values on a coordinate axis, okay? So important thing to remember is the period over which sine and cosine repeat themselves and come back to the same value is always 360 degrees or 2 pi radians, all right? So let's pull these orange coordinates, these y coordinates, and I'm gonna just focus on y equals the sine of theta. So these are gonna be the y coordinates on the unit circle, because in the unit circle, again, we know y corresponds to the sine of theta. So if I pull these guys, when theta is 0, right, then the y coordinate is 0, right? When sine of theta, theta being pi over 6, right, or 30 degrees, right, the y coordinate is 1/2. At pi over 4, which is 45 degrees, right, it's rad 2 over 2, which is about, if you put that in your calculator, about like 0.7-ish. We're just gonna sketch it so it doesn't have to be perfect. Then pi over 3, right, if I were to sketch my special right triangle, I would find out that the sine at 60 degrees would be rad 3 over 2, which is about 0.86, you know, like 0.9-ish, okay, if you put that in your calculator. Then if we go to pi over 2, which is a quadrantal angle, right, and we think about our unit circle, then the sine of theta, the y coordinate, is 1, all right? Then 2 pi over 3, right, this is where we have our repeating values. The reference angle there would be 60 degrees if I were to draw that, okay? So then the sine of 60 degrees is, again, rad 3 over 2, right, which is 0.9, right, like we talked about earlier. Then 3 pi over 4, right, that would put us here, which means we would have a 45-degree reference angle. And that would give us a y coordinate of rad 2 over 2, right? So it's the same thing here as here, a reference angle is the same. So then that would be about 0.7. And then 5 pi over 6, we drew that in there, gives you a reference angle of 30 degrees. The sine of that is 1/2, right? So we can pull that right off our unit circle, so that's about 0.5, right? Now you can see I'm just kind of using my quadrantal angles at this point, okay, and then we'll sketch this. At pi, sine is 0, right? 3 pi over 2, which is 270, right? That would be -1. And then, being that it's a periodic function, right, at 2 pi, after that period, it's going to repeat the same value and come back to 0. All right? These are the values we're going to graph right now, okay? Theta is going to go on my x-axis, right? And these guys, right, the outputs are going to go on my y-axis. So here, I'm going to start at 0, right? Then I'm going to put my quadrantals, which I've kind of darkened, you can see here. as we move forward, you'll see these are going to be our critical points, which we've been talking about with other functions, okay? And I'm going to have you graph 5 critical points as opposed to 3 with some of our other functions, all right? Now, you can see the highest value I reach, right, as far as my sine of theta is 1 and -1, so I'm going to put that here and here, and then maybe -0.5 and then 0.5, okay? And then I'm gonna sketch this, okay? So this is about 30 degrees, right? This is 90 degrees, so that's about 1/3 of the way. It just is a sketch. 45 should be somewhere in the middle there. This is pi over 6, pi over 4. And then this guy, right, is 60, so that's about here. So that's pi over 3, okay? And then we'll do the same thing here. So 2 pi over 3, then 3 pi over 4, which is really, right, halfway between these two guys. And then last but not least, we have our 5 pi over 6. And then, again, I'm just going with our quadrantal angles after that. Now, to see the general shape here, we sketch or plot our points. So that's at 0, 0. Then pi over 6, I'm going to hit 1/2. Then pi over 4, or 45 degrees, I hit about 0.7. Then much closer, 0.9. Right, somewhere about there. And then the maximum, right, we've used that word before, pi over 2. Then I'm going to come back down, right, hit 0.9 again, 0.7, then 1/2. And then back down to 0. And then here, this guy's gonna hit 3 pi over 2, right? My sine of theta at that value is -1. It's a little bit low there. And then back up here, we're back at 2 pi. So now, this should be a nice function, right? That curves, okay? It's not a straight line. So you want to kind of repeat that curve here. This would continue if we wanted to, okay? And then we also want to continue the same values here. So if I have pi over 2, then I have -pi over 2 here, don't I? If I go the reverse way, then I have -pi, -3 pi over 2, and then -2 pi. Now, if we go the opposite direction, right, and we start here, this is a periodic function. So we start at 0, which we have here. Then if I go -pi over 2, that's going to hit at -1. Then I'm going to continue around. This is -pi because I've gone the opposite direction, so that hits at 0. And then I'm going to go -3 pi over 2, which is also pi over 2. That's going to happen at 1. And then, last but not least, at a -2 pi, I hit 0 because of that periodic function. And then I can continue my curve, okay? That's what a sine curve looks like, okay? If you unwrap the unit circle and just graph the y-coordinates, okay, the sine function, all right? Now, you can see the domain, right, can continue forever and ever. I graphed from -2 pi to 2 pi, but this is technically all real numbers, right? Your range is your mins and your maxes, right? So here, we're always going to be graphing from, unless we transform it, -1 to 1. My amplitude, okay, and this is a new word for you, okay, is going to be the height of the curve from the midline, and I'll talk about that in just a minute, or the sinusoidal axes, okay? So It's the height. So height is never negative, all right? Just keep that in mind. So we're talking about the height here from the sinusoidal axes. That's the midline. I'm going to use that word most of the time. That's the line right down the middle of your curve. Okay? So your amplitude is going to be the maximum height here from there. So here, this is your amplitude. Okay, so if we don't transform this, the amplitude of a sine function is always a positive 1. Okay, and then if you remember, we talked about the period, right? Is how long it takes to see a full curve. Now, what is a full curve? Well, a full curve is where we start to repeat the same values. So we started in our table at 0, and then it took us all the way till 2 pi to reach all the values within the function and then return to 0. So for a sine function, the period, unless it's transformed, is always 2 pi or 360. All right? So that's our introduction to sine and cosine. We'll just sine right now, and then I'm going to make our next video where we talk about graphing cosine.